Hey guys, what's up? How are you all doing? Today we're looking at TryHackMe's new walkthrough room bypass, and this room is 3 days old. Kudos to lead RCE for the room. It's quite a nice room, and let's just get on it. I'll first connect to the TryHackMe VPN, and okay, wait. Outside of an alias for my lab, it'll connect me right away. Okay, so let's just make a directory for it. Cool. And I've also I'll show you this mcd bypass. So I'm right now in bypass. So what's mcd is it's just an alias. So wait, is it not in there? I made it an alias. cd scripts cat alias. Oh wow. It's not in there, but it's still working. So it's just make cd and like make a directory and cd into that, right? So I just created bypass and I'm directly into the bypass. This is handy. Uh, so let's take the IP and let's just go for a basic nmap scan. And in last video I showed you guys I got an alias for nmap basic. It will make a directory scans and it just do the basic nmap with the switch for basic scripts and tech d4 for faster scanning and tech sv for version scan and tech on to save the nmap output into this file. So let's run it. Nmap basic and to the IP. Let's wait for it, and till then we can manually check ports that are open. Like okay, SSH is open, port 80. Like we can make a HTTP request, and port 80 is open too. Server at default port 80. It's Apache, right? So yeah, port 80 is open and port 443 is open too. So HTTPS is also open. Let's just go to port 80 and it's forbidden. And if you try accessing port 443, need to go to advanced and accept the rest and continue. Okay, it's forbidden too. It's probably because this machine probably has a host setup and we have to add like something like bypass.thm to the etc host file to be able to access it. Let's just wait for the nmap scan and it's done. So if you look at in here like common name cctv.thm, right? So we can add this cctv.thm in our etc host file, and if we now try to access the page, should be right, should be working. Yeah, right. So it's a basic login page for CCTV panel of some kind, and it requires a password for us. Okay, so these three ports are open. Okay, so what is it? The network security team has implemented state-of-the-art protection mechanisms using an IDS. IDS is basically intrusion detection system, and it's just like alert us about like unauthorized access or some attempts like to evade the network security policies or something, right? So including detecting unauthorized devices connected to the local network and unauthorized users accessing a system or modifying a file. So it just does that, right? So and gain access. We have to gain access to the CCTV web panel of the company. Cool. So what is the flag value after accessing the endpoint? cctv.thm fpassword.php forget password.php id1. Let's go do that. And invalid attempt, you haven't completed the prerequisites to get the flag. So what I'm getting is we have to do some steps, or we have to perform some tasks to be able to view the flag. And I'll just go with directory brute force first. Let's just try. I'll just try to brute force some stuff here. THM. Let's see what else it got on the web server. I'll use seclist directory web content. Okay, discovery web content directory to medium. Right, and let's use 20 threads and let's just run it. Oh, okay. Let's just wait for the output. Let's see what we got. Okay, we got mail. Let's check what's on the mail. .thm mail. It's quite a good room actually. And okay, we got dump.txt. We can copy the link and we can duplicate it, or we can also view it on the web. Right. Let me make it bigger. So it's from Steve to Mark and important credentials. Hey Mark, I've completed all the formalities for securing our CCTV web panel on port 443. I've installed Suricata. Suricata is an IDS for uh, it's like it's an IDS, it's an open source intrusion detection system and intrusion prevention system to prevent. The difference between detection system and prevention system is detection will only detect and alert about it. Prevention will also take some actions to prevent the unauthorized access or some attempts from even happening at the first place. Okay, so right, okay, let's move further. To automatically detect any invalid connection and enable two-layer protection for the web panel. Cool. And we can recover the password only if we send some specifically crafted packets. Right, so we're not actually evading uh, an IDS here. We're just doing like a CTL thing, right? So we have to perform these 5 tasks. We have to perform these 5 tasks to get these 5 flags, and we'll probably get the password here for the web panel, right? Okay, so the first task is make a UDP request to the machine with source port number 5000. Once done, you can fetch the flag from ID1, right? We can fetch the flag here after sending a UDP request from source port 5000. And there is cameras too. Okay, let's search for cameras. Let's see if I have infected this one out. Cool. It's just okay. Alright. Okay, let's move on with the CTL. I don't think we'll need any further. Okay, I'll do it, and let's just create a Python flag1.py, and let's just add a shebang line to tell the script that it's a Python script, and I'm gonna do it with socket. So you can even use ChatGPT for making the scripts, how to send a UDP request using socket, or you can just take a look at the Python UDP documentation, like socket documentation, right? UDP request in Python, and it's here like UDP communication. It's the Python documentation, and it says right here how to perform a UDP request in Python. You can take help from here, and right, so we're gonna do it. I'm gonna walk you through it. So let's just create a function, send UDP request, and it will require server IP, server port, and a message that we can send, right? Because UDP requests usually require 2 or 3 arguments, right? So now what we're gonna do is we're gonna create a socket to tell the socket that we are trying to make a UDP request. How we're gonna do it is sock dot hold up. Let me reopen that. I'm not a good programmer, but yeah. Okay. socket.socket, and we're gonna tell it that it's socket.af inet. It's basically telling that we're dealing with IPv4 addresses, and another one for telling it that we uh, we want to do a UDP request, right? It's sock underscore dgram, like UDP stands for user datagram, right? And as you know, UDP is not a connection oriented protocol, so the connection doesn't establish and we can send the packet. So there's a difference between UDP and TCP, and I think we're gonna make both the scripts for tasks 2 and task 1, and in the next task we need to make a TCP request to this endpoint with a custom user agent. Like user agent is basically a header in request that will tell you that tells us uh, from where we are accessing the website, right? So usually it's like Mozilla Firefox or Chrome or like nmap, and the header would be like nmaps something. You get me, right? So we have to send a TCP request to this endpoint with a custom user agent. I'm Steve Friend, and once done, I can fetch the flag from ID2, right? Okay, so we're gonna make these scripts side by side so you can understand it better. Uh, Hold up, let me add the shebang line, import socket, and we're gonna make function here, send TCP request, and we're gonna it still needs server IP, server port, and a message. Okay, so we're gonna create a socket, socket.afnet to deal with IPv4, and socket.sock, and here instead of datagram it will be TCP stream, like to tell it that we're dealing with TCP. And now what we're gonna do is we're gonna bind sock.bind to 0.0.0.0 and 5000 port on our end. Like it's the port we wanna listen to for UDP data. Like when we send a UDP request to the server, we'll receive some data in response. So that's what we're doing right now. Yeah, and we need to specify binder to listen to that. And next we can specify a try block to send some request, and we can send sock.send to uh, message.encode and server IP, server port, and next address, the data address. Wait, where did it specify data address? Sock.receive here will receive sock.receive from 1024. I'm gonna explain it like, okay, so try and sock.send all to server IP, server port. I think we first need to connect to sock.connect server IP, and we need to just send the data, not port here. Message.encode. Right. Okay, so just hold up. And data sock.receive 1024. Okay, so the difference here between UDP and TCP, here we established a connection first, like sock.connect. We connect to the socket first, so we know who the sender and who the receiver is already, right? In TCP because it's connection oriented, and in UDP we just directly send the message to the server IP and the server port. There is no connection established. So in Here we use send to, and here we use send all, because now we can send all the all the data and payload that we want and between the server and the receiver. Here we need to specify each time which server IP and which port we are trying to send the data to, right? And same here, we receive two things, data in return and address, like the sender's address. That's why we specify receive from instead of just receive, because here we only receive the data. We don't receive the address because we already know who the sender is. The connection has already been established, right? So this is the main difference between TCP and UDP. Like UDP is not connection oriented, and now we can just print the data dot decode whatever the data is, and we can specify a finally block here to close the socket. And now we can use our function. So let's just specify the variable server IP. What was the IP? And server port we can just send to 80. And now we can use our function send UDP request to server IP, server port, and the message we can specify a get request to any endpoint, like maybe like let's just send to password. What was that? F password.php id is equal to 1, and let's specify http 1.0 and r/n/r/n. Slash r is basically a carriage return character that will return that will take the cursor to the start at the starting of the line, and slash n is like the next line, like a new line character. And it's just a way to in HTTP request, the end of the HTTP request requires an empty line. That's how it knows the request is complete and no other headers are required to send the request. Like the request is complete. It's just a way to define a request, right? So if we just try to save it and run it, python 3 flag 1.py, let's just complete this one too. We can print the data here, data.decode, and let's just add a finally block to close the circuit. And same, specify the IP, specify the server port 80, and now we can use the function to send the request, server IP, server port, and same here. It specifically mentioned request to this endpoint with the user agent Steve friend. So the slash means after the IP, like the root of the folder, root of the web server, right? So now we can specify host, cctv.thm. We can specify a user agent, and it specifically said send a request as I'm a Steve friend, right? We're gonna use that, and that's the end of the request, I guess. Yep. So let's just save this one too, and let's run it. Flag2.py. Let's just run the first flag, and it said requires more than 2 or 3 arguments. Okay, so we need to, where did we fuck up? Message that uncalled, send to, okay, send to message that uncalled. We specified the server IP, server port. What's there? Oh, bro, I think we need double parentheses here. If we run it now, yeah, it's successful. So if we just try to refresh the page, we should see the flag one, right? So that's how we send a UDP request using sockets in Python. Cool. I don't know if it's gonna return anything. So, and the major thing about it here that when you're sending a UDP request to the server, it's important that the server can accept UDP traffic, that it can interpret UDP traffic, right? And I'll show it to you later. And now we can send the TCP request to you. Server port is not defined. Did you mean server port? Uh, oh, I misspelled it here. Bro, my Vim is acting on. Cool. We sent a TCP request successfully and we got the data response in return. And if we just try to access the ID2 for the flag 2, we can view it. Right. So here is our second flag. And now let's move to the task 3. Send a ping packet. So we have to make a ICMP request, right? To the machine appearing as Mozilla browser. So right here we use user agent as a Steve friend. Here we need to user agent as Mozilla. Once done, you can fetch the flag through this endpoint. Okay, cool. So here we can, so right now we can't view the flag. We can search for Scapy Python documentation documentary. Lol. Okay, so let's just make another file for it, flag3.py, and specify the shebang line from scapy.owl import everything, and let's make a function def send ICMP request. It will require just a destination IP, whatever you can specify, server IP, whatever, and we can search for ICMP request. We can also use a row socket to, like we use the TCP and UDP one, we can also use a row socket to send an ICMP request, but I'm gonna use Scapy because it's just single line and it's super easy. So classical ICMP ping can be emulated using the following command. So we just need to specify IP and the destination IP and then ICMP function that we are dealing with ICMP, and we can also specify a row function to send a custom payload to the server, right? And the custom payload would be the user agent, that would be Mozilla. So let's just look at it on action. So we can specify a user agent that would be Mozilla, and we need to, and the row uh, wait, and the row payload that we're trying to send to the server with the ICMP request, it's user defined, right? It can be anything. It can be text or a string or some bytes. So making we're just encoding it in UTF-8, so it will be in proper format. And next we can specify a packet that we're gonna send to IP. We're gonna use the same line, IP and destination IP is equal to destination IP, as we specify the argument here, and slash ICMP, we need to do an ICMP request, and we can specify a row, and load is equal to payload that we're gonna send with it, and then we can just do send packet. That's it. That's all we need to do, and then we can use the send function ICMP request cctv.dhm. That's it, and we can run it. Python 3 flag3.py. Okay, sorry, I again did a typo here. Row operation. Oh, it needs sudo permissions to run because we're doing ICMP, and send one packet. So we successfully sent a ping packet to the machine appearing as a Mozilla browser, and we can view the third flag now. Cool. So now the fourth flag. Regarding the fourth flag, I don't know what it meant that we need to attempt a login to FTP server with the content containing the word user in it. Once done, you can fetch the flag from endpoint 4. But when I moved to the endpoint 4, we already saw the flag. I don't know. It's just weird. So let's just go on with it. Maybe just needed to like just try to log in, like just I don't know. FTP is not even on the server. Like FTP port is closed, and we can check it. Like if you want cctv.dhm and 21, it's nothing. Like we should see here FTP, right? So I'm gonna quit it. And the last flag, for the last flag, we also again need to send a TCP request to this endpoint flagger.cgi with a host header containing more than 50 characters. Once done, you can fetch the flag from endpoint 5. Okay, so again we need to send a TCP request, so I'm going to edit the above script, and we just need to make some changes to the request. Instead of this endpoint, we need to send a request to flagger.cgi endpoint, and it said the host header should be more than 50 characters, right? So we can just do something stupid, Python 3, and like just print a 50 times, and just copy and paste it to the host header, and save it, and now try to run it. Flag 2.py. We already sent the request, and now we can view the fifth flag. That was that. It was super easy. So we got our first 5 flags. Now what do we have to do? After receiving all the flags, you can visit the machine IP that will ask you for the password. The first password will be concatenated values of all the 5 flags you have received above. Okay, cool. So the password it was asking here was the combined value of all these 5 flags. Okay, let's just save it. Nana pass.txt, and jeez. Okay, you can also you can also use ChatGPT for like to make yourself a script. Like just ask ChatGPT to give you a script using socket library that will make a UDP request to this endpoint, and it will give you that. Copy pass.txt. What is the password? This is the combined value of all the 5 flags, and I think we can access the page. Cool. So okay, we again see a login page. For the second layer of security, I've enabled a wholly sandboxed login environment with no connection to the database and no possibility of command execution. Okay, so the username is the computer's hostname, but we don't know the computer's hostname, and the password is the same as previous password. I will SMS you the details. Blah blah blah. DevOps engineer. Oh, DevOps. Okay, so to get around this stage, we're gonna take a look at this source code of the page, and if you look closely, it's a drop down menu and a login page. We can try something like cctv password is the same, and it says failed to login, right? So it's doing a post request, and this seems some weird, right? Let's just try to understand what is it doing. So it's adding an even listener DOM content loaded. So whenever the document, like whenever the page is loaded, basically, okay, it's performing some things. It's creating a variable form that will get element of my form ID from HTML and a drop down menu. I'm guessing this one, right? It's getting the commands. Okay, so and it already gave us the hint. if you check it here, I've enabled a wholly sandbox login environment with no connection to the database and no possibility of a command execution. So we have to find some way to execute commands on this host, on this machine, right? So we have to find RCE basically. So I'm probably thinking this is a way, right? So now then it's an adding event listener to submit the form basically if something is changed in the form. Okay, and it's reloading the page basically, just like we're doing after login, right? Okay, cool. So let's look at the form tag. That's the here, and the first ID is my form. It's basically grabbing. Uh, where is it? Okay, form, and it's my form. And another one is command, and it's basically select option, and option one is current date. And if you look closely with the value date, date is also a command in Linux. And now look closely. Look at the output here. Sunday, April 7, Monday, April 8, the time, AM, and the UTC 2024. It's IST because I'm from India, and 2024. It's exactly the same output. So I'm guessing if we try to copy it, and let's just copy it and right click and inspect this one, and here right click and edit as HTML, and we can add another option by let's just change the date. Let's just change the value of it and just put a host name, right, and click out of it. And now if we click on the drop down menu, now there are two options. Let's just click on the second one that we just created, right? The page will refresh, and what you will see is here is bypass. So the content changes, right? So what is that? It's basically command execution. We call the command execution on the machine, and it's the host name of the machine. And it says right here, hold up, that the username is the computer's host name. So the computer's host name is bypass, and the username is bypass too. So what is the username? It's bypass. And it also told us to run this command lsp release -rs to check the lsp release version of it. And we can check it again by just copying it, and let's just change the value of date to this that command lsp release -r-s and selecting it again. Okay, I need to add another one. Wait. Let's just copy paste it. Oh god, what am I doing? Okay, so it's 20.04. That's the LSP release version of it. And what is the flag value after logging in into the CCTV web panel? I think we can log in now. The password is same as the above, and the username is bypass, same as the host name. And we log in, we are logged in. These are the gifts that we saw at the cameras, and this is our final flag. Such a cool box. But one more thing, uh, we got command execution on the box, right? So let's just try to root the box and gain their shell. Let's just try to gain the web shell. Okay, let's just log it out of here and right click and inspect it and add it as HTML, copy the value of it, and now we can just put a basic bash reverse shell, bin bash -i greater than ampersand that TCP is like redirection operator. So 240.1337 because we're listening on 1337 port, and let's just complete it, and that's cool. You can also get it from the revshells.com. Put in your IP here and the port number you're listening on, and it got a bunch of lists of reverse shells. Like you can get everything here. So you can just copy it and paste it here. So bash-c is basically we're running a new interactive bash command in another bash session, right? So yeah, if we just select that and we check, we got a shell. So we are onto that machine, we are onto that box, we can run commands interactively. And okay, so let's just stable it. Does it got Python on it? It got Python on it. Python 3. I'm gonna stabilize my shell from pty sudo terminal session spawn a bin bash and export my term environment variable to xterm for using clear and this basic terminal. Now we got a stable shell. We can control C and we won't get out of the shell. Okay, so now to root it, I rooted the box by using Ryan's latest tweet on Twitter. So I'm going to show you guys a very cool Linux exploit that just recently got out. And this was a tweet where Ryan said, while the XZ backdoor was all over the place, this incredible exploit seemed to slip by. And it's got the GitHub REPL link, and it's universal local privilege escalation proof of concept exploit for CVE. You can later research on it. What was it about? It's a kernel level exploit in the net filters functions and kernel that deals with networking data and all that shit. I don't perfectly know that, but yeah, we're gonna use this one. So let's just clone the repo, and I'm gonna move on my machine and just gonna clone it, and let's move inside it. We can use make command to build it, and we got an exploit here. So it specifically said working on most Linux kernels between version 5.14 and 6.6, right? So let's just check if our kernel is vulnerable to it. So we got 5.14 and it's vulnerable. So let's just test it. Let's just see if it works. I'm gonna start a Python server, and here it says fileless execution is also supported in case of pentest situations where detections need to be avoided. However, Perl needs to be installed on the target, right? So let's just check if it got Perl in it. Which Perl? It got Perl in it, so we can just directly use this. Let me edit it. Perl.txt. Just need to change the curl URL. Panda8.4.242. And I got an alias for copy. It's just xclip selection copy -I and add $@ just copy and specify the file name. It will copy it into your clipboard and we can paste it. And fail to detect overwritten PTE is more PTE spray needed. Okay, that's new. Wait. Did my box just got slow? Did I broke the box? Wait. No. What happened? Hold up, let me get the shell again. I think I broke it. What's going on? Okay, we got it. So we can route it that way. I'm gonna show you right now. Just wait. I don't know why it didn't work. That -C. I'm gonna use this. Right. I'm gonna stabilize my shell. We can also use script. Okay. just telling the script. A script is basically used to record your terminal, and -q for quiet, -c to run a command, and we're just spawning a bash shell with it, and then exporting our term to xterm, and now we get a stable shell. So okay, so cd temp, and we're gonna copy paste that perl command again. We're gonna see. Okay, yeah, we got it. We got it, guys. So we are root on the box. We rooted it successfully. Thanks to Ryan for letting us know the exploit. And it was a very cool box. And if you know, the box got Suricata installed. If you remember it, mail, and you see it told us that formalities for securing our CCTV web panel. I have installed Suricata. I'll show you. You can find Suricata. Oh god. Let's see. Suricata. Bro, don't. This is where Suricata config, and this YAML file will defines all the rules, and it's a very long file. I'm not gonna show it to you that. And it just defines rules and log file where to store the alerts or the attempts that anybody is trying to access the network or trying to get unauthorized access on the machine. And this was a box, so it was a very cool box, and hopefully you learned how to make requests, how to make a web request using sockets, and yeah, it was pretty cool room. Alright guys, so next time, see you.